Hi everyone, I wanted to take a moment to discuss the identity function with you. This is probably one of the newer functions that we'll be working with in Math 141, so I did want to give you a reference to work with. I've gone ahead and written down the function for you in purple over here. And I wanted to kind of show you how we're going to evaluate it and how we're going to graph it. So, as before, when we were working with this function, we would basically be saying that if I put a 2 into this function, I'm basically taking my input value and putting it in the denominator of a fraction that has a numerator of 1. So, in other words, in the case of -2, if I put -2 into the function, I will get a -1/2 out as my output value. If we were to continue to do this, so if we put -1 in, we would get 1 over -1, or we could simplify that down to just -1. So it just so happens that what we put into the function, we also get out from the function. This is just how it happens in this case. However, when you get to putting 0 into the function, we kind of run into a problem, because what you are told to do then, or your output, is 1 over 0. And that's basically saying, I want you to take the number 1 and divide it by 0. And this is not possible, or we would say does not exist, or we can abbreviate that as DNE. The reason why this does not exist is because I'm telling you to take something and divide it into nothing. We can take something and break it into smaller pieces, but we can't take something and completely obliterate it and say it was never there. We can move things, but we cannot destroy them. And then as we continue, we would get the following outputs. We would get 1 if we input 1 into the function, and if we put 2 into the function, we get 1/2. So I'm going to go ahead and plot these points. So at -2, we're at -1/2. And at -1, we have -1. I have to skip over 0 because, again, it does not exist. And we do have a point at 1, 1, and we have a point at 2, 1/2. So what I want you to know here is that this isn't necessarily enough information for you to comfortably connect everything. You can refer to your textbook to see what the shape should look like, but I'm going to offer you a little bit more info. So the fact that 0 is not able to be used into the function, we will learn later on that it kind of generates this invisible barrier that prevents your lines from crossing. This red dashed line that I'm showing you here is known as an asymptote. It kind of acts like an invisible fence or barrier that prevents the line of your function from crossing it. So it's like a wall. So what I want you to kind of note here is you might need a few more points here. So let's say we pick something like, let's go ahead and try putting in 1/3. I know that working with fractions isn't necessarily ideal, but let me go ahead and show you what happens. We'll probably need a little bit more space here, so I'm going to go ahead and do that over here. If you put 1/3 into the function, you get something called a complex fraction, because you're taking a value and then dividing it by a fraction. This looks pretty nasty. We can go ahead and translate this so that this can be read as 1 divided by 1/3. So the division bar that you have in your complex fraction is basically just turned into this division sign. Okay? So in order to finish evaluating this, we would skip the first value, the 1. We would flip the second fraction, and this changes it into a multiplication problem that we can easily go ahead and work through. This becomes a 1 times 3, so when I put a 1/3 into the function, I get 3 out. Hence the reason why this is called the reciprocal function. What's the reciprocal of 1/3? It's 3. So if I were to plot that point, 1/3 is a little ways over here, and so the point 133 is right there. If you notice, this generates this weird curve that's going to happen, and the points, and we'll explain this later on in the course, as the points continue, as the x values continue to increase, the points are just going to get really, really close. The y values, or your outputs, are going to get really, really close to 0. Your line here will not cross the x-axis. We're going to see a similar image happening if we were to, say, for example, use we'll use negative 1/4. If we put that in, you can already tell me what the reciprocal of negative 1/4 is, but I'm going to go ahead and prove it. So, again, I have this nasty-looking complex fraction, but thankfully I can rewrite it because this is saying 1 divided by negative 1/4, which now we can skip the first value, take the reciprocal of the second value, and we make it into a multiplication problem. So, if you were saying that the reciprocal of negative 1/4 is negative 4, you are correct. So if we were to come over here, our point would show up around here. So as you can see, we would get a similar shape. So here's what our reciprocal function looks like. I hope that this has offered you a little bit more insight into how to work with this problem. Let me do one more for you. So I'm going to scoop this up and out of the way. Let's go ahead and take a look at the cube root function. So f of x is equal to cube root of x. Recall that your input value is the x variable. The output value is represented by this function notation f of x. F of x is also giving you instructions on what to do to that value. So when you look at a cube root function, the name gives it away. It's saying whatever you put into the function, you need to take the cube root of it. So if I were to go ahead and quickly put an x and y axis here, and I'll also put a table of values. If you were to work with the standard -2 through +2, you're going to get irrational numbers. So in other words, you're going to get numbers with decimals that go on forever and don't have any sort of set pattern. So I'm going to go ahead and be very deliberate. I'm going to pick numbers that are perfect cubes. So in other words, that they're numbers that we can get by multiplying a different number together 3 times. So for example, I might pick -8, -1, 0, 1, and +8. Again, I'm being deliberate here because these are nice numbers to evaluate. They're going to come out really clean and therefore be really easy to plot. So if we were to go ahead and do that, if I do, if I do f of -8, then we would do the cube root of -8. So remember that the index on this root is odd, so I am able to take the cube root of a negative number. If we were doing square root, however, that's when we could not. Okay, this ends up being a -2. If we put -1 in, cube root of -1 would just be -1. So again, -1 times -1 times -1 will result in a -1. If we do f of 0, cube root of 0 is really easy to go ahead and evaluate. It will just be 0. F of 1 will be very similar to what we had previously looked at. We'll get an output of 1. And then f of 8, or sorry, yeah, f of 8, shouldn't second guess myself, we would say that is 2. So again, if we were to break this down, into its prime factors. 8 breaks down into 4 times 2. 4 breaks down into 2 times 2. And lo and behold, we've kind of shown here that the cube root of 8 is 2. So if we were to go ahead and plot these, so we have negative 8 at negative 2, negative 1 at negative 1, negative 1, negative 1, 0, 0, 1, 1, and then 8, 2. And we can go ahead and connect those points. So just a few parting notes before I end the video. What I do want you to note here is this is a function because it does pass your vertical line test. And a common error that is sometimes made, or a mistaken observation that is sometimes made, is that people do not think that this is a one-to-one function. However, what I want you to be careful of is that when you get to the outer reaches of the function, so kind of out here and out here, this value in this case is constantly increasing. So you're going to see it sloping upwards the whole time. Very similarly, if we were to continue to follow this line, it would continually move down. So it's a slight trick of the eye. It looks initially like your line is going to level off and becomes perfectly horizontal. However, on the right-hand side, the function is going to continually increase, kind of sneakily, if that's a word. And then on the left, it's going to slightly slope down each time. So that's why it will pass the horizontal line test. I hope that this video was helpful. If you do have any feedback or any questions, please feel free to come to me. Thanks.